Now we will quickly go through this video as our all topics are finished. So this is our final exercise, that is basically you can say exam style questions. Let's read it and go through it very quickly. There is the first question. A company owns a number of vending machines. Data is sent from each of these machines at the end of the day. The day contains amount of money taken, products sold, and any error conditions and reports. The company uses both echo checking and ARQs. Describe how echo check works. Explain whether this is a suitable error checking method in this application. Then there's a second question for ARQs. And then it is asking for the checksum and check digits. So we have already studied these things. These are just simply those questions that we can do from the lectures. Let's read their answers quickly. In echo checking, what happens when data is sent from one device to another? The receiver sends the data back as an echo, and then the sender compares the returned data with the original data. If they match, it is assumed that the data was transmitted correctly. Whether it is suitable in this application or not, echo checking is not suitable. Why? Because vending machine, while it provides a basic way to detect errors, it is not reliable because it doesn't detect all types of transmission errors. Network delays or intermediate issues could cause false confirmations, especially when large or critical data like sales or error reports is involved. More robust methods like ARQ are better suited for this method. For this. So how ARQ? ARQ is basically error detection method and correction method that involves the following steps. Sender transmits data to the receiver. Receiver checks the data for errors using techniques like checksums. If the data is correct, receiver sends an acknowledgement to the sender. If the errors are detected, receiver sends a negative acknowledgement. Upon receiving a NAC or no response, the sender retransmits the data. This process continues until the data is correctly received or a retry limit is reached. Then there's another, that is difference between checksum and check digit. Checksum primarily used for error detection in larger data sets like files or packets of data during transmission. It sums the binary values of the data to produce a checksum value that is transmitted with the data. Basically, what how checksum works, we have already studied it in our lectures. And then there is a check digit. We generate the check digit mainly used to validate the identification numbers by adding a single digit at the end. How we add it, we have done the last two lectures for it. Then there is a data size checksum designed for use with larger data blocks and such as messages or files. Check digit used with short sequences of numbers, typically a single digit added to the original number. Then error detection capability of both. Checksum detects a wider range of errors, such as errors in binary data, but may not catch all errors, especially if certain patterns align. Check digit detects simple manual errors like transposing or mistyping a number, but is not suitable for complex errors or large data sets. Explain each of the following computer terms: packet switching, cyclic redundancy check (CRC), and then data skewing and universal serial bus and parity bit. We have studied it in the starting lectures, so let's do about the packet switching. It is a method of data transmission. Data is divided into blocks, or you can say packets. Each packet travels independently across network through different routes. At the destination, the packets are reassembled, and this method is efficient because it allows multiple users to share the same network resources. And if one route becomes congested or fails, packets can take alternative path. CRC, this is an error checking method, and uh, it is used to ensure the accuracy of data during transmission. A mathematical algorithm generates a CRC value, like a checksum, from the data being transmitted. The CRC values are set along with the data. The receiver performs the same CRC calculation and compares the result to the transmitted CRC. If the two CRC values match, the data is assumed to be correct, just like a checksum. Then there is a data skewing. It occurs when data transmitted in parallel over multiple lines arrives at slightly different times due to differences in signal propagation speed or path length. This timing mismatch can cause errors in interpreting the data. It is especially a problem in parallel transmission over long distances where maintaining synchronized data arrival across multiple wires is challenging. And then we have a universal serial bus USB. We have already studied that. USB is a basically standard for connecting peripheral devices like keyboard, mouse, and other printer-like devices. USB is widely used. It supports hot swapping. Hot swapping means devices can be connected or disconnected without powering down the system. And it provides data transfer and power through a single connection. USB supports various speeds and versions such as USB 2.0, USB 3.0, and USB-C. In the earlier computers, we used to have a problem that whenever we had to attach a new hardware, we used to have to restart our system to make our operating system detect it. But with USB, this problem was solved. Then there is another thing that is called parity bit. A parity bit is a simple form of error detection used in data transmission. A single bit is added to a data byte to make the total number of ones either even or odd. When the data is received, the parity is checked. If the number of ones don't match the expected parity, an error is detected. Parity checks are useful for detecting single bit errors, but it cannot detect multiple errors in the same data set. Now there are different. We have to arrange these statements in the correct order. That in what order our request is sent and the data is sent on or received. So let's see these four statements for a single action. Four statements talk about ARQs are given below, but they are not in the correct order. Let's put them in the correct sequence. The sending computer waits for a period to see if the receiving computer acknowledges. This isn't the first statement because first the data has to be sent. Let's find out which way. The sending computer transmits a block of data to the receiving end. So number 3 is the correct first statement. And then we have then the sending computer waits. Of course, after sending it has to wait. Then we have after a set time period, a timeout occurs which automatically triggers the resending of the data. Okay, and then in the end we have the fourth statement that is called this continues until the receiving computer sends an acknowledgement that the data has been received. Okay, it has already told that this is about ARQs, so this will be the sequence for this statement. Answer is also already mentioned here as well. Now there are other 5 statements, so their answer is also matched. I think everyone can do that. Let me quickly go through it. The sending computer uses a block of data to calculate the checksum using an agreed method. And the sending computer sends a block of data together with the checksum value. And then we have number 3 statement. The receiving computer uses a block of data it receives to recalculate the checksum using the same method as the sending computer. So what has happened? Sending computer first generated the checksum and then it sent that, and then what the receiver did, receiver recalculated the checksum from the data, and what happened then, the two checksum values are compared, and after that, if two checksum values don't match, the receiving computer requests the data to be retransmitted. Then there are another 5 statements, 2, 3, 1, 4, 5. I think everyone can do that. Just remember this answer. And so I think these questions are easy. The question number 4, all statements, everyone can do that. So describe what is meant by symmetric encryption. Symmetric encryption is a method of encryption where the same key is used to both encrypt and decrypt the data. This means that both the sender and the receiver must have access to shared secret key to securely communicate. The key must be kept private and securely exchanged, which can be a challenge. Of course, it is difficult uh, uh, to maintain the security with that. Describe what is meant by asymmetric encryption. It uses two different keys, public and private. Symmetric uses the same key. The public key is used to encrypt the data, and only the corresponding private key can decrypt it. The public key can be shared openly, but the private key is kept secret. This method is more secure for key exchange since no shared key is needed. Next is explain why encryption is used when transmitting data over a network. Basically, it is used to maintain security, confidentiality, and it prevents unauthorized users from accessing and intercepting our information. And even if a malicious party intercepts, malicious party means any hacker, without the decryption key, the data remains unreadable for them. A file server is used as a central data store for a network of computers. Rory sends data from his computer to a file server that is approximately 100 meters away. It is important that the data is transmitted accurately. Rory needs to be able to read data from and write data to the file server at the same time. We have to take that which transmission is used. A file server is used as a central data store for a network of computers. Uh, let's say uh, Rory needs to be able to read data from and write data to the file server at the same time. He has to do it at the same time. Explain why your answer to A1 is the most suitable data transfer. Transmission is suitable because serial transmission is so the answer if to it is serial and duplex. Duplex means full duplex. Why do we need serial? Because it is suitable because it can efficiently transmit data over longer distances like 100 meters with reduced stress. So and the full duplex transmission is selected because Rory needs to send and receive the data at the same time. So this is why the duplex is used. Next is basically this is the advanced topic that is not the part of our syllabus, but uh, this is the thing that we will be studying in A levels. This is called quantum cryptography or secure communication, A levels computer science, and in advanced encryption using physics based on quantum mechanics used for ultra secure data transmission. What is quantum cryptography? Let's quickly go through it. It uses laws of quantum physics instead of mathematics, uses photons for data security, energy of photons, creates near unbreakable encryption systems mainly used in secure communication over fiber optic cables. Why it is important? Traditional encryption based on mathematical difficulty, quantum cryptography based on physical laws. If data is intercepted, it changes automatically. Intruder can be detected. Used for banking, military, and the other systems. Quantum key distribution technique for sending encryption keys securely. Most common protocols BB84 share encryption keys without being hijacked. Uses quantum properties of photon. What is qubit? Basic unit of quantum information. Unlike classical 0 1, qubit is at 0 and 1 at the same time. Superposition only becomes definite when measured. Makes interception detectable. Polarization of photons. Photons can be oriented in different directions. Two main bases, rectilinear basis and then diagonal base. Each basis can represent 0 or 1. Encoding bits in photons, rectilinear basis 1 equal to vertical, 0 equal to horizontal, diagonal basis 1 equal to slash and 0 equal to backslash. Sender chooses basis randomly for each photon. Measurement rule. If same basis use correct result, if different bases use a random result, 50% chance of 0 or 1. Measurement disturbs photon state. Original data may be lost if basis mismatches. So let's see how it's going to be. Sender chooses random bits, chooses random bases, sends photons accordingly. Receiving photons chooses random basis for each photon, measures incoming photon, does not know sender's basis initially. Public comparison. Sender and receiver publicly compare which basis was used. They do not share actual bit values, only basis information is shared. Key extraction keeps only bits where sender and receiver use same basis. Discard all mismatched ones. Remaining bits equal to secure encryption key. Why it is secure? If attacker tries to intercept, they must measure photons. Measurement changes photon state. Sender and receiver detect interference. any eavesdropping becomes visible. Real world use, secure government communication, and these are basically uses. That's all for this. Basically, what is the different in quantum? It uses physics, not math. It is based on photons, qubits, polarization, and QKD, key description, key decryption, secure key exchange, and detection of eavesdropping, and BB8 for the main protocol. That's it for the chapter 2. Next, we will go to chapter 3.